Welcome to the Real Python Podcast. This is episode 56. Are you looking for a bit of order when working with dictionaries in Python? Are you aware that the Python dict has changed over the last several versions and now keeps items in order? Could you learn more about object-oriented programming in Python by comparing it to another language? This week on the show, David Amos is back, and he's brought another batch of PyCoder's weekly articles and projects. David covers a real Python article about the differences between the OrderedDict versus a standard dictionary in Python. We discuss a recent video course about how object-oriented programming in Python compares with Java. And we cover several other articles and projects from the Python community, including what is Werkzeug, building a full-text search engine in 150 lines of Python code, loading SQL data into Pandas without running out of memory, how to beat the Berlin rental market with a Python script, replacing print with icecream, and the new version of CircuitPython and Mu. This episode is brought to you by DigitalOcean's app platform. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, David. Welcome back to the show.
Hey, Chris. Good to be back.
So this week we got a real mix of things.
Yeah,
I'm kind of excited about a lot of them.
a potpourri.
Yeah, exactly. We got a few different sort of project kind of things. Of course, a couple of real Python articles. What do you got first?
Yeah, the first one I've got is by Leodanis Pozo Ramos, who is one of our premier authors at this point. He's pumping out a bunch of good stuff.
Yeah, people hear his name a lot here.
Yeah, he's very prolific for sure. This article is called OrderedDict versus Dict in Python, the right tool for the job. And I was really happy to see this article come out because it's one of these things that a lot of people get confused by if you've even heard of OrderedDict. So first of all, I think, there's probably listeners out there who don't know what OrderedDict is. So you have this built-in dictionary type in Python, which is sort of like, like dictionaries are just everywhere in Python. And it's like a key value table in a sense, right? So you have keys and they are tied to values. And the advantage is that you get really fast lookup of values by their key. So you can just access that key and it'll spit back the value that's there. And it's basically constant time performance there for looking up a key. Up until Python 3.6, dictionaries didn't have any order. If you were to use, for example, there's this method on a dictionary called pop item, which allows you to just remove an item from the dictionary and it spits back a tuple with the key and the value in it and removes it from the dictionary. So you can kind of like destroy the dictionary with this pop item and get items out of it. And it would just return like a random key value pair. There was no order to it. When you would iterate over a dictionary, there was no order to how things were iterated. So there was nothing about the dictionary involved any kind of order at all. In 3.6, that changed. And well, I guess I should back up and say that if you needed a dictionary with an order, then you would use this OrderedDict type, which is available in the collections module. And that always kept a last in, first out kind of ordering, right? So it's basically insertion order. And then if you needed to pop things out, then you would get, by default, you would get the first thing that you put in. When you iterated, it would go off of the insertion order. But then you also had the option of sort of shuffling things around, and you could pop items from like the last thing that got inserted into the dictionary, or you could move things to the end, things like that. So if order was important, then you would use this OrderedDict. If order was not important, then you would just use the standard built-in dictionary type.
And all those methods were built in with that particular type.
Exactly, yeah. And OrderedDict is actually a subclass of the dict type. So it has essentially the same API, but then adds a couple of things onto it to handle the ordering.
Okay.
And there's some algorithms where, you want like an ordered key value table kind of thing. So it made sense to have this type to make it easier to kind of implement those kinds of algorithms. Well, in Python 3.6, they did kind of a massive overhaul of the dictionary type in Python. And it was not a specified consequence, or what's the right way to say this?
Happy accident.
Yeah, it kind of like a happy accident was that in the process of optimizing a lot of things about the dictionary, it was maintaining insertion order. Now in 3.6, they said like none of this is a guarantee. It's kind of just this unintended consequence. Don't rely on it. But so many people loved it that in Python 3.7, they decided to guarantee this last in, first out ordering for dictionaries, the built-in dictionary type. So then the question is, okay, well, if dictionaries now are ordered, then why should I even care about this OrderedDict type? Like, does it just cancel it out? Like, what's the difference? And why should I even use it? So that's the goal of this article, is to explain what the differences are and why there are times that you would want to use an OrderedDict versus just a standard dictionary. And just to kind of summarize why the answer is yes, that you still need an OrderedDict, is that one is, it signals intent. By using OrderedDict, you're making it very clear that the order is important here. OrderedDict also provides you some measure of control over the order. It's got a move to end method that can move items to like the end of the dictionary. It's got this modified pop item method that can pop from either end, and it's optimized for that. So you get fast removal either from the beginning of the dictionary or the end. And then also equality test behavior. So even though dictionaries, the built-in dictionary type is ordered, if you compare two dictionaries that have the same keys and values, but they were inserted in a different order, those will still compare as equal to each other because the order is sort of incidental. It's not like a feature necessarily of the dictionary. It's still kind of an unordered type, even though it does have this order. However, for an OrderedDict, if you have two of them that have the same keys and values, but they're in different orders, then they will not compare equal to each other. So again, it kind of goes back to like, if that ordering is really important, then the OrderedDict is generally the right choice. Now, the article goes on to talk about how you exploring all the different features of Python's OrderedDict type, how to merge and update using different operators, performance considerations between the two, which in general, the built-in dict type is usually faster, for kind of the basic operations. And then like a kind of a handy guide for selecting the right dictionary for the job that you're doing. And then a nice little application that it kind of shows you how to build like a dictionary-based queue out of this. So kind of a little applying OrderedDict to something you might see in the real world. So it's a pretty cool article, and I think will really help solidify people's knowledge of, why these two types exist and why you would use one over the other.
Yeah, that all makes a lot of sense to me. The idea that the intent is really being specified the minute you see that import statement.
Yeah.
You're making these constructs around, something that you're going to want to always be maintaining it throughout. Something kind of going back to the refactoring conversation that I had, like this idea of like showing what your intent is through how you're programming things, not just purely in documentation, but by how you're sort of setting stuff up structurally, is pretty crucial. Can really, sort of explain, where you're headed with these things. It makes me think a little bit about there's a series that Christopher Trudeau's been doing, taking this Python tricks, been turned into a real Python article that's sort of like selecting the right data structure.
Yeah.
He has a little bit about it there, but this sounds like a nice deep dive on it, going even further into a lot more of the why, which is great. My next one is called What is Werkzeug? And I always have a hard time pronouncing that word because it's German. I had a talk with Armin Ronacher way back in the show. I'll get the episode number right here in a minute. But he was talking about how when he was creating Flask, he had all of these sort of bits and pieces and tools and he ended up calling the overall thing the palettes project. And there's kind of a nice conversation that we had about that. And where the name comes from, work is basically work, and then Zug is like stuff. And so, it kind of relates to like being like tools or a toolkit, which is kind of interesting name. And what it's really doing kind of underneath it is, doing this sort of heavy lifting of the HTTP functionality and not having to do all the sort of WSGI, which sometimes is pronounced WSGI, web server gateway interface stuff. It does a lot of that work for you. It's of like connecting to that and setting all that up. And the article takes you through kind of a deep dive of, well, how could you create something with just Werkzeug itself? Which is kind of interesting. Normally you would go ahead and use Flask, which uses Werkzeug as a dependency, but to kind of tear it apart and see the inner workings of what this actual set of tools does is actually kind of cool. It's a very hands-on, very detailed article kind of going through building up a little simple application. In this case, it actually does have a data component where you're using Redis, which actually was able to use with Docker really easily, which was kind of nice. I didn't have to install Redis on my machine, which is very cool. It's by Patrick Kennedy. He writes on Test-Driven IO pretty often. And I just enjoyed it as a exercise of seeing the inner workings of what kind of Flask is building on top of. It's like very often you take these frameworks and you work with them at this higher level, and you don't get to see how these things integrate and what is happening kind of on the lower level and what goes into those kind of components. So if you're interested in that, you do web development stuff, or you want to learn more about it, and you want to kind of see like, okay, well, what is Flask building upon? What's kind of getting handed over? It's a neat tool taking you through that. And I thought it was a good way for me to deepen my understanding of like, okay, well, how do these Flask applications kind of tie together? And then, there's this whole templating thing with Jinja templating, Jinja 2, I guess it is.
Yeah.
Anyway, I had a lot of fun kind of playing around in it, and it's a well-structured project that you could work through and through the process learn actually what is Werkzeug.
Yeah, and I think also kind of come away with an appreciation of some of the things that Flask is doing for you. Right? That's
yeah, definitely. You can create Flask applications so quickly.
Yeah.
In the case of like we've talked about visualization stuff, and very often they'll use Flask as this very simple set of tools that can be set up within a handful of lines, and you got this web server hosting your visualization, be it in something like Dash or what have you, or Bokeh, which is pretty slick that it can do all that kind of work for you. And this is like, taking you down into the the inner workings of what's happening.
Yeah, for sure.
This episode is brought to you by DigitalOcean's App Platform. DigitalOcean's App Platform is a new platform as a service solution to build modern cloud-native apps. With App Platform, you can build, deploy, and scale apps and static websites quickly and easily. Simply point to your GitHub repository and let App Platform do all the heavy lifting related to infrastructure. Get started on DigitalOcean's App Platform for free at do.co/realpython. That's do.co/realpython. So what do you got next?
Next one I've got comes from someone named Bart Digard. I hope I'm pronouncing that correctly. This one is cool. It's called Building a Full Text Search Engine in 150 Lines of Python Code. And it's true. It's a full text search engine. It only takes about 150 lines. One of the things that's kind of neat about it is it uses as the data set it's like 6.27 million article abstracts from the English Wikipedia.
Wow.
So it's millions and millions of documents. And you're able to search these things and get like a list of relevant documents in like milliseconds.
Wow.
And it talks about kind of, everything that's involved in doing this. You learn kind of the basic components of a full text search engine. That's things like, indexing and searching, and then how to compute the relevance. And one of the things that I learned and I thought was interesting was, how they're actually computing that relevance. So they do this interesting thing where they first kind of compute like the term frequency, like how often does that term appear in a document? And then also something called the inverse document frequency, which is like kind of a score of like how rare something is in the document, and they multiply that by the term frequency. That's kind of like their scoring mechanism. And he doesn't go into like a lot of detail of like why you do that or like what's really going on there, but he links to some really cool resources about what that is, and so we can throw those into the show notes as well, so you can have a better feel for like why you're actually computing relevancy this way. But once you've kind of got all these pieces together, you've seen how to index things, you've seen how to like actually search through things and then compute the relevancy. Then you tie it all together, and you've got this full text search engine over this data set of documents. And one of the things that I really liked about this was I've come across, a lot of times these articles on natural language processing, and it talks about like the basics. You've got like tokenization, lemmatization, stemming,
right?
And for example, in the indexing part, you use this tokenization and stemming, like to set things up for like the search and all that kind of stuff. But in a lot of articles, they kind of stop at these very, I use the term trivial, not as like a derogatory
right
term, but just it's sort of like it's a minimal example to sort of show you like how something works.
So they could publish it back to practically.
Yeah, but it doesn't give you any sense of like, how do I actually use this in the real world? It's like, okay, I've seen how to like tokenize some text, but like, why would I do that? What's the application here? So this kind of introduces you to some of those concepts, but in the context of like building this like really useful tool. I mean, if you would be able to take this same thing and say you had, a huge document library at your work that was difficult to search, and it was all, had a bunch of text in it, right? Then you'd be able to take this and basically take that data set and rework it using the same kind of code and build something extremely useful where you'd be able to search through those documents extremely quickly. So it's just a really cool article. It's also not very long, but it's got all the code in it and a link to the GitHub repository, and also kind of some ideas for some future work, things like that. I'm not sure if this author plans on expanding on this article at all, but regardless, it's pretty self-contained. You walk away with everything you need. It's very cool, and it's a quick read. So very good stuff.
It sounds like it's kind of a bit of a crossover into the natural language processing. Doesn't sound like it's using external libraries, or is it using the kinds of things that you'd see in data science, scikit or keras or things like that?
So it is not really using, it's not using any of like what you'd think of like NLTK or keras or like any of these data science type libraries.
That's really interesting because it's like kind of this crossover between the two worlds. Like you don't think of like people that are building search engines per se delving too deep into like neural networks and building those kinds of things, but it's an interesting crossover in the sense that you're doing a lot of that low level, you said tokenizing and kind of creating these vectors of like, how often do these words occur, and then creating like a rating system. And it seems like it might be a neat project to kind of even build off of if you wanted to learn something from that.
Yeah, exactly. Yeah, it's got three. I'm looking at the requirements txt file in the GitHub repo now. It's got three dependencies. One of them is LXML, which is specific to the Wikipedia documents, because when you get that data set, it's like a giant XML file.
Yeah.
And then the other two, it's also got requests, I think, because it's using requests to get the data set from that. So two of the three are just related to the data set itself. The third one is something called PyStemmer, which I'd not ever heard of, but that's a stemming library specifically for text. So
cool.
That's it.
Yeah, that's neat.
Yeah.
That sounds like a fun project. I was interested when that came up on PyCoders and wanted to dive a little deeper into it. So it sounds like something I might need to go a little further into. My next one is from former guest Idemar Turner-Trowing. He has a new article up on Python Speed, and this one's called Loading SQL Data into Pandas Without Running Out of Memory. And so
Yeah.
this has been an ongoing conversation that I've had, and we've had that conversation even with Idemar, and how he's built this tool called FIL, FIL. It's a memory profiler tool. And I haven't had a chance to really play with it a lot, but it was neat to actually see it in this article, sort of, I don't know, in action, if you will. He gives the output multiple times to kind of show you how the thing looks at stuff and how it kind of like, creates this report kind of coming out of it.
Yeah.
But anyway, he wanted to really talk about this problem that when you're loading in SQL, there's multiple places in memory where all that data is sort of held and has to be sort of parsed. And so there's kind of problematic ways of doing that, depending on how big this query is. Like, are you querying, a million items and so forth? And so he has these examples where he talks about, okay, iteration number 1, just load the data, 1,000,000 rows. And the problem is all the data in memory, but multiple times. And so in his particular example, the memory, I think, is like maybe it's around 100 megabytes of raw sort of data. And by doing this multiple times, it ends up being like 400 megabytes. Again, depends on your system.
Yeah.
And again, we're talking example article length type stuff here, and so, but there are systems, or very often we talk about resources out there on the web, cloud computing and so forth, that where you have to kind of plan for how much you're going to use. But the problem is it's going to read all the memory. The SQL cursor tool is going to fetch all these rows, and then the tool, like something like SQL Alchemy, this ORM, if you will, is going to do manipulation on it. And then Pandas converts it into tuples to be able to eventually do another step of converting those tuples into arrays. And at all points, all that's in memory. It's not like it's sort of holding all that while those things are happening. And so it end up being a bit of a big bottleneck, and you get this out of memory error. So he comes up with a second iteration, which is this idea of sort of an imperfect batching of like, okay, think about these basic techniques of memory reduction. And the two are sort of batching things up or chunking things. And the read SQL tool, pandas.read_SQL, has an API that helps for chunking. It's actually literally a chunk size parameter. And so you could say, okay, I really want to do 1,000 of those rows at a time. And so that will help a lot and cut it down. But the problem is the data is still in memory.
Mm-hmm.
And the cursor execute's still going to read all that memory, and then sort of like, while it's holding it in its arms, sort of take handfuls of it over and hand it to Pandas or SQL Alchemy as it kind of works. So those things are going to free up memory as they go, but the main cursor is still going to read all of it in. This is his solution, which is kind of where the whole article is kind of leading toward, which you should check out. It's a thing that a lot of people are maybe not as familiar with, the idea that there can be server-side cursors, which is really more of the idea of actually streaming the data out.
Yeah.
And in this particular way, then there's this parameter that's called connect, and you can have a sort of a thing called stream results that you can flip into being true. And then at that point, it's actually going to stream out the results instead of holding on as like one big cursor call in memory. And he writes at the end of it, which is kind of a funny conclusion. He's like, Pandas should probably be doing this automatically, especially if you're using chunk size. And there's an open issue about it. Hopefully someone, perhaps you, will submit a PR.
Yeah.
So I like that call to action inside there. So anyway, it's a neat, again, if you're doing data science-y stuff, you're loading lots of data into SQL, you're working with Docker stuff, Idamar's site, Python Speed's really got a great set of resources for you to check out. And this is just another example of, kind of diving into like, okay, well, where does all this stuff kind of sit in memory, and give a nice example of ways to kind of shave off that, and then also come up with potentially a better solution of just truly streaming the data out.
Yeah, man, I really like Idamar's tutorials.
Yeah.
one of the things I really like about it is he's really great at like picking a super specific issue and writing like a very short, but like heavy hitting article about it. And I just think that's great.
Yeah.
Like this, it's like this very specific issue, and there's like a ton of value packed into just this like short article that takes like probably eight minutes to read.
Yeah.
8 to 10 minutes to read. Yeah. That's good stuff.
He's very good at finding pain points, and kind of like sort of honing in on like, well, this is where I had all my trouble.
Right. Yeah.
Which is good because I think that's a common thing.
Yeah.
Is that we all kind of run to the same sort of hard pain points and say, okay, let's look at ways to work around them.
Absolutely.
So what do you got next?
Next one I've got is a lot of fun. It's not a super technical article. For example, there's like no code at all in the article, but it does talk about like some code related things, but it just was a really cool kind of case study in how you can use Python to solve an everyday problem, like something that it like is not work related, that's not even, and at first like might not even seem like a technical problem. So the article is called "How I Beat the Berlin Rental Market with a Python Script." It comes from Gian Segato, and the problem is this is kind of the problem that he was running into. So Berlin has a massive undersupply of housing, and renting really like doesn't have anything to do with your spending power as much as it's just like competing with other people, like just trying to beat the competition.
Right.
And it kind of goes like this. You apply for a property, you go visit the property with like a dozen or so other people there, and then you just kind of hope and pray that the landlord will select you at the end of the day, and you'll get the property. And there are kind of two things that influence like how selectable you are. One is your profile, which, is probably includes things like your credit or history or things like that, or, your job history and, that. So like that's something you can't really change
right
very quickly or like, in the short term, it's just kind of fixed. And then the other thing that influences like whether or not you're going to get selected would sort of be like the speed with which you can do things. Like, are you the first one to apply? Are you the first one to come visit? Like, you just kind of like, making sure you're the first person that the landlord sees and they kind of stick in their mind kind of thing. So he talks about, there's kind of this naive strategy that a lot of people adopt, including himself, I guess, when he was kind of first starting with this, was if you're the first one to visit, if you're the first one to view the property, and if you can be the first one to apply, then that's going to give you a little bit of an edge for, over the competition. The problem is though, then you're kind of making this like significant financial decision like very quickly, like in the matter of like hours or minutes, which is like not really a smart or wise thing to do. And, the key to being able to make a good decision quickly is knowing whether or not the price is actually any good. Are you getting a bargain or are you just making a decision based on like FOMO? But in order to make a decision like that, you have to know the market. You have to like understand like
history too,
how pricing works and like all that. So he decided to write a Python script that would scrape rental data, and it used like kind of a variety of factors, geographic location and rental history, and just all sorts of stuff kind of went into creating a what he calls like a market alignment score.
Yeah.
And so that would be like kind of like, how far away is this from what market value should be? Is it like significantly above or significantly below? So kind of help you determine like, is it expensive? Is it cheap? Or is it, pretty much like right where the market, would put it? And then also it's kind of like some experimental features, did some work to calculate the likelihood that the rent was about to be sold out. So that like it was about to, basically like, you got to move quick, or like this is going to be, they're going to pick someone. Or if there was a likelihood of like a price decrease, because sometimes he says that, landlords will set a price and even though they're getting like some applicants, that they just may not think that like it's the right kind of applicant or something. And they may see that as like a sign that I need to decrease my price in order to like be more competitive. He kind of had this like compute these likelihoods of, is it about to be sold or, rented, or, is it about to have a price decrease? It's all to kind of help him just find a good place to live. And it worked. I mean, he was able to get into a place.
All right.
He does say, at the end of it, like, he's not really sure, like, was all of this overkill? Was it really necessary?
Right.
He's like, I don't know. But in the end, like, he had fun doing it, and he learned a lot about the Berlin rental market, which he found interesting. And now he is turning it into a little bit of like a web app so that other people can kind of use this tool, kind of see, how expensive things are and how likely it is to, go have a price decrease and everything. What I really liked about this was just that, it takes this problem of, which is, I've got to go find a place to live. I have to, find rent in this like competitive market. And you can use Python to help you kind of maybe gain a little bit of an edge. And by not doing any, like, there's nothing shady going on here, right? Like, you're not like using Python to like rapidly fill out applications, like, you know what I mean? Like, give you some kind of like, it's really just like analysis, like just,
right.
And so I thought that was really kind of a cool idea. And then it's turned into this idea for potentially a service that he can offer where people can just kind of type in an address and see, like, is this too expensive, or is it a good bargain right now, or things like that. So
yeah,
very cool. Again, like not technical. He does talk about, though, like kind of the architecture, like, what kind of database he chose, and just some very general discussion of how it works, some of the libraries that were used and things like that. So it does kind of come in that does mention some of that stuff, but again, I didn't find any link to like a code base or anything for you to look at, but still, it's a fun read. It's a quick read, and maybe it'll spark some creative ideas in your own mind about things you can do with Python.
I saw, I guess it was an article recently just about New Zealand and all these people wanting to move there, and how it's just like kind of crazy, the type of bidding where it's almost like this like huge auction hall kind of situation, where it's gone beyond just a handful of people.
Yeah.
And it's just sort of crazy. And the Hawaii market, since we moved 2 years ago now, just exploded. It's just gone on and up from there in kind of a similar way. And I have a friend who's looking for a house there, and he's just struggling, because it's just like kind of this exorbitant, huge raise of prices, but also just when we went to look, timing was really crucial. Like, I agree with that. Like, some people are just super motivated. They want to get a good person. If they like them right away, then they'll just, close right away. So that timing, I totally agree, is like very, very important part of it. And we were ready to go as soon as we could with our realtor.
Yeah.
Which was nice. And then, but the other trick is, so many of these places are like total fixer upper kind of things, like they're like a shack, kind of situation. And the pricing is just, it doesn't make any sense. And so you have to really decide, like, well, what did this originally go for? And, like what I need to put into this, and so forth. And, am I buying the land literally as the only like asset here versus like a, something, I don't know. I had a friend who was like, oh, they're all tear downs. And I'm like, okay, well,
yeah,
that's a little drastic, but yeah. And it's very expensive to build there too. Like getting raw materials to Hawaii is very expensive.
Right. Yeah.
And so it's like, everything is kind of like this weird kind of escalation of factors. So I could see this as being a useful tool for him, something like this, just to scrape all the sites that are out there, Zillows and what have you, and just to be able to create some kind of alerting system just so he can be on time. But I understand, like, all those sort of factors. It kind of goes back to your search thing too, like where you're kind of creating these sort of internal algorithms of like, okay, well, how should things be weighted, and how should I decide? And, there's only so much time you have as a human being. So if you can use technology to sort of supplement that, so you're like not, just having to troll through everything and look at all the details. And so,
yeah,
it's great. Yeah. I think that's a super neat project. So my next one is a real Python one. It's a course by a new instructor, Howard Francis. Howard Francis decided to take this article that we have already on the site that was called Python versus Java, and it's about learning the differences between the two languages and learning them from the aspect of, okay, well, Java is truly an object-oriented programming language. Everything in Java is an object. And you might have heard us talk on and off here that we say that Python is also everything inside of it's an object. But there are big differences between the two. And so I really wanted to focus on that a little bit and talk about what goes into it. And in the course, it's a pretty long course. There's a lot of detail that goes into it here. He starts out by just showing you, okay, what are sample classes in both Python and Java, kind of comparing what they look like, so that if you see the two of them, you can kind of sort of identify the two. Or again, if you're coming from Java, you'll be able to see all these sort of architectural differences inside of Python and get an idea of it. Then you go into declaring and initializing your classes, looking at class attributes, the concept of public and private, which is very different between Python and Java. The idea of access control is a pretty deep topic that goes into, you've probably seen working with objects inside of Python, the idea of self. In Java, it's this thing called this. And so you see that kind of compare and contrast between self and this. Then you get into, functions and methods. And I learned a little bit about Java there that I didn't know, that you can't really have these sort of standalone functions the way that you can in Python, how Python can be really used as like a scripting language, the idea that you can have all these little standalone functions. So that's very different. And then by the end of it, you're kind of diving into inheritance and polymorphism and multiple inheritance, and then sort of these idea of types. And then something, again, we've done this deep dive a few times talking about these special methods and the idea that there's these default methods that come with objects inside of Python, and kind of how that's similar in Java and how it's a little different. And then finally, you kind of wrap up into operator overloading and reflection. So it's a real nice deep dive into this topic. And I found it as useful for learning object-oriented programming in Python as some of our other courses that are on it. Like, because it really had to go through the process of showing you object-oriented concepts. And then he goes out of his way to not only show you in slides kind of what's going on, but then showing actual, importing those objects in and kind of playing with them and working with them. And so it's a really great course. I've gotten really good feedback on it, and I think you guys will enjoy it a lot. And again, not just for those people coming from Java. For me, it was kind of the other way around. Like it was neat to kind of see the differences between the two, coming from Python primarily, and seeing how other languages kind of structure things really taught me a lot more of like, oh, that is kind of neat and unique inside of Python. And so it's a good resource. I think you'll enjoy it.
Yeah, this is one that, I've got bookmarked to watch. I guess one of the unfortunate things about working full-time for Real Python is that I don't have time to like actually consume all of Real Python's content.
What?
And, yeah. And, the like 90% of my work life revolves around the written content on Real Python. So there's a lot of the video content that I just don't get around to watching. But this is one of the ones that I saw it and I was like, okay, I have to watch this at some point. Like this is got to bookmark this. And it's about an hour, so it's not terrible. I carve out an hour somewhere.
This week, I want to shine a spotlight on another Real Python video course. It's a course that I covered in this episode, and it covers the deep topic of object-oriented programming by comparing two languages. It's titled Python versus Java, Object-Oriented Programming. The course is based on an article by previous guest John Fincher, and in the course, Howard Francis takes you through how to build a class in both Java and Python, explore how object attributes work in Python versus Java, compare and contrast Java methods and Python functions, discover inheritance and polymorphism mechanisms in both languages, investigate reflection, and apply everything you've learned in a complete class implementation in both languages. Although the title seems to imply you need to know Java to get the most value out of this course, I have to say that isn't true. After going through the course, I have a deeper understanding of objects in Python. And by the end, those coming from Java, I hope you'll be able to apply your knowledge of object-oriented programming to Python. understanding how to reinterpret your understanding of Java objects to Python and use objects in a Pythonic way. And like most of the video courses on Real Python, the course is broken into easily consumable sections, and you get code examples for techniques shown, along with each course having a transcript and closed captions. Check out the video course. You can find the link in the show notes, or you can find it using the newly enhanced search tool on realpython.com. I heard a little secret that maybe you might be making some video courses or something.
I will be working on some video courses to go along with the Python Basics book.
All right.
So that is something that actually it's kind of like the primary goal for me for this week at work is to get that first course done and out the window and hopefully get that
into the hands of the editors and everybody else.
Into the hands of the editors and I can move on to the next one. So yeah, I don't know how long it's going to take to kind of get through everything, but there's I think 18 chapters in the book, and I think 17 of them are like would be course material. One of them is just like a kind of like a final thoughts, like more like an epilogue than it is a chapter on coding. But so definitely coming up
cool
here in the near future.
Looking forward to it.
Yeah, me too.
So that brings us to projects, and I have the first project this week, and everybody will love this one. It's called Ice Cream. So it's spelled ice cream with no space, and I don't know. I'm a little dubious of what they claim. Their short description is never use print, the print function to debug again. And partly why is that the print function by itself doesn't do a lot. And this one actually, as a sort of a replacement for print, does way more. It's much shorter because you just type IC for everything that you want to print out. But what it will allow you to do inside of your applications, if you have the habit of sort of doing some debugging as you go and trying to figure out things as you're moving along, sometimes you want to see, the outputs of a particular function, or maybe you want to see where something is working inside of a function. This can kind of show you that. It imports a pretty print and a couple other tools to kind of tell you sort of programming context. It'll tell you, like the file name, the line number, what the parent function is if you want. So these are all kinds of things that are built into it. It's a neat library, and the output is kind of neat. It actually prints out like IC pipe, and then it'll actually have what you were trying to print next to it. And I don't know. I think it's a slick little tool to add to, some of the additional things. Like we're talking about having a conversation about these sort of alternative tools to help you learn more about Python by sort of using Python and exploring inside of it. And I think it's kind of neat that way, like the idea of like inspecting things and seeing what's happening. And if it takes too long to type out all the stuff in print, this could maybe speed some of that up for you and give you a little more information. Not quite truly debugging. That definitely would be a little more interactive and a little more kind of controlled. This is more something where you want to be able to, kind of print things, but also see what's happening with it as it's kind of going along and working with it. So check it out. I did have a little bit of trouble with trying to use ice cream inside of an alternative REPL. It didn't seem to like the sort of live REPL sort of experience as much. And so I'm thinking that's something they may work on a little bit more. They show us some examples of using it that way, but it kept giving me a few errors. So that's something I might actually mention to them in it. But a neat little project. And the funniest thing I thought about it is the very last line of this whole thing is delicious ice cream should be enjoyed in every language. And so they're working on, Ruby and R and Go and PHP. And so they have all these projects across everything. So pretty ambitious as far as like going in and giving you some additional places to see it being used. And
so I just got a comment here though, that, for Ruby, the name of the package is rice cream. But for Java, it's just ice cream dash Java. And I'm wondering why that's not coffee ice cream.
Yeah, there you go. Mocha.
Yeah.
Something.
Yeah, mocha.
Well, yeah, the R one is just ice cream.
The R one's just ice cream.
Yeah.
The Dart is just ice cream.
Or
Maybe there were already packages called
could be
ice cream.
C++ is ice cream CPP. So
yeah.
Anyway, that's funny. Rice cream.
Rice cream. Yeah.
I bought that before.
Rice.
All those kind
ice
of
cream.
alternative lactose-free ice creams. So
I could see that being pretty good, actually.
Yeah, it can be
done properly. Yeah.
Cool. All right. So what you got for a project or projects?
So mine, yeah, there's kind of two of them to talk about here, and it's more of like kind of a news flash more than anything. But the CircuitPython project has now released their version 6.2.0, which is just awesome to see that project continuing to evolve. They're supporting lots of new things, new hardware and things like that, and different functionalities. So some of the things that they've added, kind of like a big one, kind of an enhancement, I guess, is they've updated the built-in help output for localization, which is a pretty cool change. They've added some TCP server support for the ESP32 board, and there's some other kind of board specific changes. There's an initial port now of CircuitPython to the Raspberry Pi.
Oh, nice.
Yeah, lots of big changes, and lots of kind of board and like port specific changes. But it's just cool to see that project just growing and gaining in popularity and everything. And one of the great things, or one of the best things to pair with CircuitPython, is the Mu editor. I pronounce it Mu, sort of like the Greek letter.
Yeah.
Mu. I don't know if it's supposed to be Mu.
Because you're a mathematician.
Yeah. I guess. But yeah, the Mu editor, they are now on their third beta release of the new version 1.1. Although the day that we're recording this is apparently they're going to come out with the fourth beta. So by the time you're listening to this, maybe they'll have that fourth beta out. But they're getting closer and closer to the next big release of that editor. And one of the cool things about the Mu editor, there's lots of cool things about it, but specifically for CircuitPython, is it's very highly integrated and has a nice environment where you can basically just sort of plug these things in like a little board that's running CircuitPython, plug it in and kind of just start going with it. And you don't have to get bogged down with making the connection and,
right,
learning, how to do all that kind of stuff. So it really does kind of make it into like a plug and play kind of thing, especially on the latest versions of, if you're on an older version, maybe it's not quite as supported, but in the latest versions, that's definitely a nice feature to have. There's also some good stuff in Mu. I'm trying to think if it was Sean and Kelly from Teaching Python that had come across. I remember hearing about this like issue with Pygame in Mu, or Pygame 0, I guess is what it was. But I'm not sure where I saw it. I know that Sean and Kelly used that a lot they used the Mu editor, I think, a lot in their teaching.
Yeah.
But anyways, there was now a recent update to Pygame 0. They've been able to go back to using the official Pygame 0 package from PyPA rather than this fork that they had created on their own that kind of had a patch in it to make it work with Mu. So that's kind of nice news. I know Pygame 0 and Pygame in general are great, kind of teaching tools. They're used a lot in education and everything. So having that support back, I'm sure, is going to be a big relief to people that are using that with Mu in the classroom. So lots of fun stuff going on there.
Yeah, no, I'm always excited with the electronics stuff, and CircuitPython keeps growing right along, and all their stuff is kind of connected to the Adafruit boards, and so every time they come out with new versions of the boards and stuff like that, and working with them, it's good to see that. And yeah, they were really working on it quite a bit. They got through like 6 betas there before they released it.
Yeah,
which is cool. All right. Well, thanks for bringing in all the articles and projects again to share with us.
Yeah, for sure. Thanks for having me.
All right. Talk to you soon.
Yep. See you later.
And don't forget, you can get started on DigitalOcean's app platform for free at do.co/realpython. That's spelled do.co/realpython. I want to thank again David Amos for coming on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.